Sketch the graph of f of x equals 1 minus 2 to the negative x. There are two terms here, 1 and 2 to the negative x. This is the difference of two terms. They are not like terms because the first term is a constant term and the second term is the exponential term. So we cannot combine these. So this is not negative 1 to the negative x. To sketch the graph, we first observe that this is a transformation of the graph of y equals 2 to the x. First, this function reflects the graph of 2 to the x across or over the vertical axis or the y-axis. And then the negative in the front, it then reflects the result vertically or across the x-axis. And lastly, it shifts the results up 1 unit. And so there are three transformations here. F of x equals 1 minus 2 to the negative x can be rewritten as negative 2 to the negative x plus 1. If we start out with the function g of x equals 2 to the x, for example, first, g of negative x is 2 to the negative x, and so this is a horizontal flip or reflection about the y-axis. And so starting with the graph of y equals 2 to the x, we would reflect it about the y-axis. So this is now y equal 2 to the negative x. Next, we put the negative in front of the result to obtain minus 2 to the negative x. But what this means is that we take the result from the previous step and we reflect it about the horizontal or x-axis. And so this is now y equals negative 2 to the negative x. And lastly, we take negative g of negative x and we add 1 to get negative 2 to the negative x plus 1, which is the function f of x. That plus 1 which shifts the graph up 1 unit. And so if the y-intercept would at 0, 1, when we flipped it over, then the y-intercept now is 0, negative 1. And so if we bring it up 1 unit, then the y-intercept is now at 0, 0. The horizontal asymptote of y equals 2x is y equals 0. When we flip it over the y-axis, the horizontal asymptote is still y equals 0. And when we flipped it over the x-axis, the horizontal asymptote was still y equals 0. But then when we shift the graph up 1 unit, the horizontal asymptote is now y equals 1. Armed with this information, we know that the y-intercept is 0, 0. We can plug 0 into the original function. F of 0 is 1 minus 2 to the 0. 2 to the negative 0 is 1, and then 1 minus 1 is 0. So we know that there is a x-intercept of 0, 0 and the y-intercept of 0, 0. And we also know that there is a horizontal asymptote at y equals 1. We might want to plot a few more points. For example, when x equals negative 1, then 2 to the negative 1 is 2 to the positive 1, which is 2. 1 minus 2 is negative 1. So when x equals negative 1, y equals negative 1. when x equals negative 2, we have 1 minus 2 to the negative of the negative 2. And so this is 1 minus 2 to the 2 is 4, so 1 minus 4 is negative 3. And so when x equals negative 2, y equals negative 3, which is a point down here. And similarly, when x equals 1, we see that 2 to the negative 1 is 1 half. 1 minus 1 half is 1 half. So when x equals 1, y equals 0.5. We draw a smooth curve that goes through these points, knowing that the horizontal asymptote is y equals 1. When we draw the exponential function, make sure the graph does not go down. If it is increasing, it needs to be increasing all the way. So try your best to not make the graph go down after some point, because it stays close to the horizontal asymptote.